Welcome to the latest episode of the MFG Radio Network's Manufacturing Matters, where industry experts take deep dives into the latest technologies you need to consider to keep manufacturing moving.
I'm Jake Kaufman, the associate editor for the manufacturing group here at GIE Media. Welcome to our latest discussion, Unlocking the Power of Software in Manufacturing. Our expert is standing by to answer questions about companies preparing to be future-ready manufacturers and how software brings speed, control, and visibility to manufacturing operations. We'd like to take this time to thank today's sponsor for the discussion, CG Tech Vericut, as CG Tech's Vericut software is the standard for CNC simulation, verification, optimization, analysis, and additive manufacturing. CG Tech also offers programming and simulation software for composites, automated fiber placement, tape laying, and drilling fastening CNC machines. Vericut software is used by companies of different sizes in all industries. Established in 1988 and headquartered in Irvine, California, CG Tech has offices worldwide. And now it is time to meet today's expert. I mean, he's an expert every day, but today he is our expert, as we have Jeff Vagley once again joining us from CG Tech, as he is a Vericut product specialist with CG Tech, a position he's held since 2016. Jeff has more than 25 years experience in CNC manufacturing and also 15 years using Creo Pro E. He received his bachelor's degree in fine arts with an emphasis in industrial design from the University of Illinois at Urbana-Champaign in 1994. After earning his degree, Jeff was an applications engineer for PTC resellers and worked at Solar Turbines as a CAM technical manager as he managed their CNC programming and manufacturing integration groups, with his most recent role as a Six Sigma black belt prior to joining CG Tech. So Jeff, once again, thank you very much for joining us today. Obviously, always fun to talk to, so I'm looking forward to today's discussion.
Definitely. Thank you very much for having us today, Jake. Appreciate it.
Awesome. So we will start off talking about verification software. So what or how does verification software reduce or eliminate the process of manually proving out NC programs?
So I think this is a great way to start off this conversation. So really the short answer to that is it saves time and finds, potentially costly mistakes, which equate to money saved, right? Which is, I usually gets everybody's attention. This gets into the prove out process for CNC machines where that gets costly. So once you've gone through and you've done your processes, or your steps through the CAM systems and through simulation, now you go down to the shop floor and you're trying to step through a program, and that gets rather timely and costly using up a machine. So what I mean by that, let me show a slide here. I think this might help just from a visual standpoint with some folks. Jake, can you see that slide there?
Yes.
Okay. So if you take a look at, we've got simply a chart here. You've got time going across to the right, and you've got money going up on the left here. And you've got your time broken down into two sections. Your production planning, typically what your CNC programmers do up in the office, generating the tool paths and whatnot. And then when you get over to the manufacturing, that's representational of what goes on down on the shop floor. So in that production planning process, right, you go through and you've got your CAD work, and then you're doing your CAM work, generating your tool paths and whatnot. And you're passing along, a CAD file over to the CAM. You get out your CL data file, and then you typically post-process it, right? So I think everybody is pretty familiar with this process. Once you're done with your CAM program, you think you've got a good G-code program, and now you go down to the shop floor and you prove that out. And what we find is a lot of people typically go down to the shop floor, they step through that program, line by line, block number by block number, just to prove that out, or they may cut like a Ren block or a Ren plastic type piece apart, or a wax blank to prove out that part as well. Then you may find some issues. I think that's, kind of the name of the game. And it's an iterative process then going between the CAM and the prove out process there. Once you finally deem you've got a program, then you go through and you do your various machining of X number of parts that you need to make. Now, keeping that in mind, if we compare that process in another way, so you go through the CAD and CAM process, you post-process that program, and now you've got a G-code that you think is good. Now you run it through a simulation software. In our case, it's Vericut is our simulation software. And that iterative process that goes on when you realize you've got a couple problems is all done up at the desk, right? Or wherever your programmer is. So that process is taken care of there. Once you deem that you've got a good program, now you can go down to the shop floor and start running your part, or at the very least, you have a much more reduced simulate or a prove out process there, and then you get into your machining of parts much quicker. Obviously, there's time savings there in that process. Now, if you take that a step further, you can also do some optimization on that program, right? So rather than just running at a standard, feed rate throughout the program for that particular tool, you can do some optimization that we'll get into in a little bit and further reduce that time. So there's some more time savings there as well that you can do in that process that can all be done prior to going down to that shop floor and running out that part. So in summary, I think we can reduce the time it takes to prove out those new programs without taking up that time, that costly time down on the shop floor where your assets are down there making you money for you. So.
Okay, awesome. Thank you very much, Jeff. Now, for shops that have older equipment, how does the verification software optimize the NC programs? And what are some other benefits that also would be brought into the process?
Yeah, so I think, a critical part of this, or a critical point to make is anytime, a shop, for your any CNC machine shop that you have, you want to make sure your assets are running to the fullest potential. Mm-hmm. And, so you really shouldn't matter whether you've got older or newer equipment. Obviously, the older machines typically don't run as fast as the newer ones. But I think the most critical thing there is making sure that you are using that asset, in this case, a CNC machine, to its fullest potential. So what do I mean by that? So if you take the NC program and you optimize it, right? You optimize it so you can get the most out of what that tool can handle. So you're pushing that tool the way the manufacturer recommended it, and then from your experience, you're running that as consistently as you can. And then as well, keep in mind what the machine can do, right? So think of it as speed limits, right? Mm-hmm. Obviously, the newer machines typically run faster. So if you can maximize those two components, then you're taking full advantage of the assets that you've got, or your CNC machines. So how do we go about optimizing those NC programs? So one of the first things we look at, we have if for anyone who may not be familiar, we have an optimization program called Force Optimization. So one of the first things you can do with that is you can just simply, work on your air cuts, making sure you've optimized them so you're rapiding over in as quickly as you can when you're not engaged when you don't have a cutting tool engaged into your part. The second part of that is optimizing that cutter to where you're optimizing its load. The best way to do that is through a constant chip thickness. So anytime, if you've talked to your tool manufacturers and that, I think anybody that's worth their salt will tell you the best way to optimize that tool and get the most out of it is to have a constant chip thickness with that. So one of the things I think to point out with mentioning that is, CG Tech works with our tooling partners, anybody from Coral Plus or the Sandvik tooling that we have, through anybody that any tooling manufacturers that you can get data from with Machining Cloud, or if you happen to have your data in a tool management system such as TDM or Zola or anything like that, you want to be able to get those cutting limits and those optimization settings, make them to where they're accessible for your verification software and for your optimization software. So the goal with that is to get a good, accurate tool geometry, but in addition to that, you also want to be able to get the good cutting recommendations from that manufacturer with the least amount of work. Hopefully you can do that with just a few clicks of a button. So if you have, as I mentioned, if you happen to be using like a TDM or a Zoller data management system, these databases have the ability to be able to put that data and import it into our Vericut software. So, and then if you happen to use an online tooling system like a Coral Plus or Machining Cloud or Novo, all of those systems have the ability to provide those cutting parameters as well. So when you get that data into our software, you can run various checks on your NC program, just making sure you're within a limit, right? That the tool only runs from, let's say, from 10 inches per minute to 20 or something like that. If you go below that or you exceed that, you can get warnings from that. Then you can also take other data and you can optimize that tool path. So if the recommended chip thickness is a couple few thousandths, you can go through, and as you're engaging in heavier and lighter cuts going through a part, you can make that program optimized and you can get to where you can run that program faster. There's a lot of other benefits you can get from that that we'll talk about in just a little bit with optimizing, or getting longer tool life. It's less wear and tear on your CNC machines. But I think those are kind of the key parts, even when you have older equipment that you want to keep in mind, is being able to take full advantage of that asset that you've got.
Okay, awesome, Jeff. So obviously one of the biggest things that people always get to talking about is the money. So how is it that you can calculate savings by using verification software?
Yeah, so I think some companies may struggle with this, and in some cases, I think it's very easy. First of all, when machines are running and making parts, obviously you're making money. If you can improve that process and reducing those prove out process that we talked about earlier, that obviously frees up more time to be actually machining and making parts. Now, if we flip over and we talk about the optimization, there's where I think you can really get some untapped savings. And I think where some companies are getting into this, I think there's a lot more companies that can take advantage of that. So for example, in our Force software, in our Force optimization software, we have a savings calculator. Once you've gone through and you've optimized your program, and it'll show you a time difference. Here's what your original time was based on a constant feed rate. Here's what your time is shortened with an optimized time. And you can plug in an hourly shop rate and all of that, and then it provides you what those savings are. I would expect that's what most people get out of, or what you should expect to get out of a simulation or out of an optimization software there. But then there's other things that I alluded to earlier, right? So if you've optimized that program, those tools that you're using you should get more life out of them. You're going to obviously then you're extending the life of that tool. You're saving some money there. There's also intangible savings where you're reducing that wear and tear on the machine. So if anybody has stood by a machine, right, and you hear kind of that machine hammering, that harder sound as it's going into a lighter cut, you know exactly what we're talking about. If you get a more constant tone as that tool is going through thicker and thinner areas it's cutting, there's less wear and tear, and you're beating on that tool and the machine a lot less. So then there's also additional savings where customers can get, I think, even from the inspection and the rework. So if you're machining more consistent good parts from an optimization standpoint, you're getting better surface finishes. Chances are you're getting more continuous good parts off of there, off the machines. So I think there's savings to be had in those cases as well.
Thank you very much, Jeff. So when it comes to verification software, it simulates the material removal process, but can the software also help then determine optimum feed rates to be more efficient for machining? And also, what are some other benefits that would bring?
Yeah, so I've alluded to some of this as well. I kind of got ahead of myself in some of the other conversations, but your verification software should have the capability to read in cutting limits, as we talked about earlier. Then utilize that information during that optimization process to push those tools to their optimum performance or optimum potential. As a side note on that, it's important to understand that some tools that you may have in your arsenal may be used in a variety of different ways. For example, 1-inch solid end mill may be specifically used for or recommended for a certain application, let's just say pocketing. But users oftentimes may use that for profiling, may use it for something else as well. So you may need to have different values for those different applications that you're going to use for that tool. So, but that's exactly what our force optimization software does. You can have different settings for how you may use it, one for roughing, one for finishing, for example, for a particular tool. And then, regarding the second half of that question, I think other benefits, what other benefits does this bring? It ties into what I mentioned previously. It improves the tool life. It reduces the machine wear and tear. You got better surface finish, and you've improved consistency of parts coming off, good parts coming off that machine.
Awesome. Thank you very much, Jeff. So how about with complete machine simulation? How does this help avoid machine collisions? And once again, what are some benefits when you do simulate a machine?
Yeah, so I think this starts to get into some of the terms that have been out there in the industry, I don't know, for the last many years, like digital twins and things like that. So if anybody's looked into a digital twin, this ties into that machine simulation. And a digital twin is really, just to take a moment to explain that in case anybody's unfamiliar, it's more than just having accurate geometry of the CNC machine. It's the ability to take that virtual representation of the elements and the dynamics of your asset, in this case, a CNC machine, and be able to display how that works on a screen, like we're on a laptop or a computer. So for CNC machines, one of the most important foundational building blocks of building that virtual simulation is the parameters of that machine, which you can look at it as the DNA of how that machine operates, right? How the various G codes work, how the various M codes work. So you want to make sure that, when you have a simulation software, it's representing exactly how that machine's operating down on the floor. It needs those parameters to be able to work with in order to understand how to build that accurate simulation. Then there's other things that go into that too, such as, for example, work offsets, your tool geometry, your tooling offsets that are in there, the NC programs and the subroutines. That's another key part of, making sure you've got a complete simulation. And all of those combined, I think, will help give you the most accurate simulation you can get right now, as well as avoid, and then using that information, you should be able to avoid any collisions, be able to see all of those things before they're actually going to happen on the physical machine. You can see by just doing that on a digital screen.
Okay. Now, just thinking of a follow-up to that, when you do run a machine simulation, is it something where you incorporate every part of the machine, or could you just kind of get it down to where it focuses on one specific area of that machine?
And that's a great point to bring up. I'm glad you mentioned this. So we have users that use our software in varying degrees. Some may do, we'll call it the most simplistic method, where they're just showing the stock and a tool going through cutting that part. Others may have more of the understructure of showing kind of the kinematics of the machine. You see a lot of the stuff that we do on the demos where we've got a full enclosure on the machine to show that entire machine built up. You can do that in any fashion. It will still show you the collisions in that. What I think are key points to that is you want to make sure that you have your setup accurate. So if you have a fixture, you want to have that accurate fixture there on your stock model. If for some reason you don't have that, that's just one of the things you obviously don't have in that simulation. But the other thing then, when you get into, you want to make sure you have accurate tool geometry. To make sure that, for example, if you're having to get down into some kind of a tight space, you want to make sure that tool geometry accurately represents what you're really diving down into, as well as the geometry on that tool. So I think those all kind of add into that, and it just really depends. The user, if a user is using in a more simplistic, maybe let's call it just a simple 3-axis type of application, they may not need all of that other stuff. On the other extreme, if you have a more of a 5-axis type of machine where you've got a lot of kinematics and tables moving around and heads pivoting and whatnot, I think it's more important to have some of that other data there so you can make sure you don't have any possible collisions or problems.
Awesome. Thank you very much, Jeff. So now that, let's say you've done your due diligence with the verification process prior to running the program on your CNC machine, what else could possibly go wrong?
So, this is actually something we've been working on and has been right in my crosshairs for the last bit here. And, how you handle that gap from going from the software, the CAM world and the verification and post-processing over to the real world, there's a lot of things that can happen then at that point. You introduce human error and variability. So if you think of your work scenario or your workflow similar to what I showed earlier in that slide, think about that you've run your simulation or your Vericut simulation, and then you've gone and you've realized you've cleaned up any collisions or any problems you may have, and then you've also optimized your program. So you have all of that set. You're now ready to release that program down to the shop floor, and it's scheduled. Now, once it's on the real machine, you've got the fixture put in there, your stock or your casting, whatever it is you're going to cut, and you've got programs loaded. You've got the work offsets and all of those different data points. You're literally ready to hit the cycle start button. What's the difference of what you had in Vericut or your simulation to what's down there on the real machine? So there's a few questions that can come up. Let me share a slide here. So I just put up a handful of questions here that I think pertain to this topic. And I would imagine many of you have gone through and run into some of these questions. Does the shop have the correct version of program and subroutines? Are all my tools set correctly? Do I have the right tool links? Is the job going to run 100%, or is it currently running at 100%? Or do they have it dialed down? The list goes on and on. There's a variety of variability that can go on when you go down to that real shop floor. So this is where I think it's critical that you try to simulate what's really going on down on that machine, really getting the true definition of what a digital twin is. So if you look at all the different modules in that, some of you may have seen this workflow before with Vericut. I'm going to focus particularly down here in the bottom right corner once you're down at the machine shop. So if you can go do a pre-check on that machine, so you can verify that you've run as I mentioned, you've run your Vericut simulation, you're ready to go down to the floor, everything is set up on the machine. But could we double check that you've got the right programs? Can we double check that you've got the right work offsets and that the tooling links are all set exactly to what's on that machine? That's what we can do now in our pre-check software. So we can do a quick check before you hit that cycle start button, verify all that data. We'll compare the two differences. If there's differences, we flag that, give you the option to update it, or in some cases, it may just simply prompt a conversation with somebody down on the shop floor saying, hey, I show different work offsets. What's going on here? Then there's also the ability that once a part has been running, go back and grab some of that data and analyze it for investigative type reasons. Maybe you're doing process improvements. Maybe you've been running parts for a day and they were good, and then suddenly yesterday afternoon, parts started showing up discrepant. Go back and grab that data and run it through Vericut, and you can check and see, okay, wait a minute, maybe there was a tool change and suddenly a tool length adjusted, and now it's starting to rub the part in that area. So you have some pre-check and post machining type of capabilities that you should be able to go do now as well. Then there's also another option that we have where you can go look at a live stream of the machine. So once you've proved that program and it's running and you want to see where that part's really at or what's that machine really doing, you can connect and see in real time where that machine is. And if for some reason somebody's dialing down a feed rate or they happen to hit an e-stop or something like that, that will show up in that live streaming capability as well. So I think those are all part of that, that element of what can go wrong when you go down to the shop floor. But we've got some solutions now that should help a user be able to avoid some of those issues, or at least flag them and focus, and hopefully then improve any problems that you may have there.
Awesome. Thank you very much, Jeff. So speaking of those users that you guys will have for the verification software, what are some examples that you have of success stories after these customers have started using the simulation and verification software and complete machine simulation?
Yeah, so I should keep that screenshot on there. So I have a couple of good examples within the last year or two. Here's just one company. This is Man Energy Solutions, where they have taken and reduced, by using the Vericut, our simulation software, they've been able to reduce their prove-out times in one case, for example, 8 hours down to 2 hours. That's quite a time reduction.
Yeah.
And I think that's a perfect example where this verification software fits into your process and where you can start to see some true dollar savings. Just as a fun side note, I don't know how well this image is coming across for some people on the screens. If you look at this image, just to give you an idea what this Man Energy Solutions does, that is a huge monster cylinder block of an engine block. So those big holes that you see by that gentleman's foot there are where the pistons go in. The piston's probably about 2.5 feet across. So I think in a case like this, you've got quite a bit of machining to do. It's a perfect example that shows where this software can benefit a customer. Here's another one from our parent company, Sandvik. So this is from their Mebane facility over in, I think that's North Carolina, if I'm not mistaken. So they run Vericut software to the extreme. They don't actually typically sit and watch the software. They run it in more of a batch type of application. So they will run literally hundreds of variations of the holders and the extension components and everything that go into a tool assembly. That's what they make, or the tooling components. But they run those simulations overnight, and then they come in the morning and they get emails and notices whenever there's an issue, and they can go investigate that. So that's just another example where they use the software to verify there's no issues, no collisions, no problems with their program, but they can do it in a automated fashion. And then I've got one more here, which is a perfect example where a customer uses Vericut, and then they've gone to the next step and done force optimization and further improved their program. So they've been able to save machine time up to about 17% here at Influx, and in some cases up to more than 45%, just depending upon the machining situation that parts that they're cutting. So those are real-world examples where we've been able to help customers use the verification software as well as use the optimization software to benefit their bottom line and save them some money.
Awesome. Well, yeah, glad you guys were able to help those people out. So we will kind of start wrapping up the presentation today. But before we go, I wanted to ask you a pretty broad question, but obviously like this is something that has changed drastically over the past, few years. But looking forward into the future, what are some kind of innovations or discoveries that you could see coming in the world of verification software, say in the next, 10, 15, 20, in the near future? What could you see happening?
Yeah, so this is really hard to look into your crystal ball and see where we're going to be at. And part of the reason is things in this world today are moving so fast. I think some of the key things that a software developer doing simulation, like what we're doing here, simulation and verification, you've got to remain agile and be able to readily adapt in a very quick manner to something that comes up in the industry. I think that's one of the key parts, is that you've got that methodology in place as far as how your company, as far as the software company performs. I think another trend that we've been seeing, and that I'm going to guess is going to continue to go on, is that we're losing knowledge out there. As the generations, perfect example are the baby boomers right now. As they're continually retiring, there is a good chunk of knowledge that's being lost. And in some cases, you're able to capture some of that knowledge and be able to reuse it. And in some cases, it's just simply gone. And I bring that up because I think that's going to be one of the key things with verification software, that the software is going to need to get smarter and make up for that amount of knowledge loss or degradation. So, and then I think one of the other areas that's going to continue to grow, as we've seen in the last many years, is the work that's being done in the cloud and cloud sourcing. We all know it's a different world now with this, with COVID and working, out of your house or anywhere else around the world. You want to be able to access that data from anywhere. And I think that's going to continue to be a continual theme in the work industry, in our industry here in manufacturing and in simulation and whatnot. So companies are going to want that software as a service, where they can log on anywhere and be able to access their data or access software. I guess, you could almost say the cloud's kind of the limit with some of that. So, but I think those are some of the key areas that we're liable to see in the next 10, maybe 20 years or so. So.
Awesome. Jeff, thank you so much for joining us today. I know everyone out there learned a heck of a lot about software. So thank you so much for everything that you added today. Great talking to you again.
Thanks, Jake, and thanks, GIE Media. Appreciate it. Bye.
You can find more Manufacturing Matters plus the MFG Radio Network's other podcasts on Apple Music, Spotify, Google Podcast, or on our websites at todaysmedicaldevelopments.com, aerospacemanufacturinganddesign.com, and evdesignandmanufacturing.com.